నీట్ 2020 ఫలితాలలో NSR ఇంపల్స్ విద్యార్థుల ప్రభంజనం. ఆల్ ఇండియా కేటగిరీలో థర్డ్ ర్యాంక్ సాధించిన శ్రీశాంత్ కు మా అభినందనలు. ఇంతటి అఖండ విజయానికి ప్రోత్సహించిన అధ్యాపకులకు మా కృతజ్ఞతలు. 2020 జేఈఈ మెయిన్ ఫలితాలలో NSR ఇంపల్స్ విద్యార్థుల ప్రభంజనం. ఆల్ ఇండియా అన్ని కేటగిరీస్లో 18, 35, 251, 253, 582, 606, 778, 780, 812, 821, 1031, 1039, 1303, 1575, 1654, 1753, 1754, 1978 ర్యాంకులే కాక మరెన్నో ఉత్తమ ఫలితాలు సాధించిన విద్యా సంస్థ NSR ఇంపల్స్. ఈ ఫలితాలు సాధించడానికి కారణమైన లెక్చరర్లు మరియు తల్లిదండ్రులకు మా కృతజ్ఞతలు. NSR ఇంపల్స్ ఎడ్యుకేషనల్ ఇన్స్టిట్యూషన్స్.
So let us continue. Suppose let us take one example. If H plus ion concentration is some 10 power minus A, let us assume like this. It is given as some 10 power minus 1, 10 power minus 2, 10 power minus 3. In general, I have taken 10 power minus A. A represents some number 1, 2, 3, 4, 5, 6 like that. Let us find its pH. What is pH? pH equal to minus log H plus. Remember, if it is aqueous solution, you have to write minus log H3O plus. H plus does not exist but exists as H3O plus. So anyway, minus log H plus, instead of H plus, what is the concentration? 10 power minus A. So this is minus of minus A log to the base 10. Remember, it is always base 10. Log 10 to the base 10 is 1. So minus A, and this is 1. So minus A into minus A plus A into 1. So we will get plus A. Keeping this in mind, suppose if the concentrations of H plus are given like this, let us find the pH. Suppose if it is 10 power minus 1. So instead of A we have 10 power minus 1. What will be the pH? 1. 10 power minus 2. 2. 10 power minus 3. 3. 10 power minus 4, 4, 10 power minus 5, 5, 10 power minus 6, 6, 10 power minus 7, 7, 10 power minus 8, 8, and so on. So ionic product of water Kw is 10 power minus 40 for water at 25 degrees Celsius. So what is this? So if concentration changes from 10 power minus 1 to 10 power minus 40 of H plus, then you can see that, right? So if H plus concentration equal to OH minus, that is 10 power minus 7, then pH is 7, and that is nothing but neutral water, neutral solution, nothing but water, right? If H plus is greater than 10 power minus 7, greater than 10 power minus 7 means 10 power minus 6 to 10 power minus 1. The solution contains more number of H plus and it becomes acidic. If concentration of H plus is less than 10 power minus 7, less than 10 power minus 7 means 10 power minus 8, 10 power minus 9, up to 10 power minus 14. Here the H plus ion concentrations are less than OH minus, therefore the solution becomes neutral. So what I can conclude is, if pH equal to POH equal to 7. In water, what is H plus ion concentration? 10 power minus 7 molar. What is OH minus ion concentration? 10 power minus 7 molar. Then what happens to pH? pH and POH becomes to equal to 7. That means this point. So here pH and POH are same. Therefore, then the solution will be neutral. Then the solution is neutral. If pH is less than 7, If pH is less than 7, that means H plus is greater than 10 power minus 7. Here 1 to less than 7 means 6, 5, 4, 3, 2, 1, right? Or we can write that POH, pH plus POH is 14. If pH is less than 7, then POH should be greater than 7. Then the solution is acidic. Then the solution is acidic. If pH greater than 7 means from this direction. So in this case H plus is less than 10 power minus 7 molar. Remember pH and H plus are inversely proportional. So if pH is greater than 7, or you can say that POH is less than 7, then the solution is basic in nature. And the solution is basic in nature. So remember at 25 degrees Celsius this is 14 by 2, 14 by 2 is 7. So in case of neutral solution, that is nothing but water, pH must be equal to pOH equal to 7. Based upon that we have concluded this. And remember this is at 25 degrees Celsius because Kw depends upon temperature at 25 degrees Celsius. So let us take one example of water, interesting example of water. Imagine that we have taken water here. So what we get, H plus and OH minus. Say at 25 degrees Celsius, Kw, this is experimental value 10 power minus 14 molar square. H plus equal to OH minus equal to 10 power minus 7 molar. pH equal to POH equal to 7. The nature of the solution, nature is neutral, it becomes neutral. When you increase the temperature, nothing but you are heating. Remember this is at 25 degrees Celsius. So if temperature is increased, it can be 50. It can be 60, 70, 80, 90 like that. So remember that means temperature should be greater than 25 degrees Celsius. What happens? What happens? Let us assume no evaporation, that means around 100 degrees, maximum temperature you are going to increase around 100 degrees because at 100 degrees Celsius water starts boiling. So even you can consider it 100 degrees Celsius, but remember not more than even you can take higher temperature, but the quantity of water keep on decreasing because it will evaporate, right. So up to boiling temperature, let us say you are increasing the temperature about 25 degrees Celsius. What is the meaning of that? When you heat it, remember pure water is a weak electrolyte, right. So it dissociates partially, there exists equilibrium between undissociated molecule and its ions. When you increase temperature, what happens? More number of water molecule will dissociate. When you increase temperature, the degree of dissociation of water increases. That means more number of water molecules will dissociate. What is the meaning of this? So the reaction moves in forward direction. When you increase the temperature, the equilibrium shifts in forward direction. More number of water molecules will dissociate, due to which the concentration of H plus or the number of H plus ion increases. But remember, the number of OH minus also increases. That means with increase in temperature, the degree of dissociation of water increases or the equilibrium shifts in forward direction, which results in increase in the number of H plus. At the same time also increases the number of OH minus ion. In simple language, the increase in the number of H plus ion will be exactly equal to the increase in the number of OH minus ion. The increase in the number of H plus will be exactly equal to the increase in the number of OH minus ion. That means, if temperature is greater than 25 degrees Celsius, Kw will be greater than 10 power minus 14. What is the meaning of 10 power minus 14? It can be 10 power minus 13, minus 12, minus 11, minus 10 and so on. Kw value. That depends upon temperature, right? So, why it is increasing? Because H plus and OH minus and both ion concentrations are increasing. Remember, Kw equal to what? H plus OH minus. With increase in temperature, H plus ion concentration increases, OH minus increases, and they increase by same factor. Therefore, Kw will increase. Kw will increase. So, it can be 10 power minus 13, minus 12, minus 11, minus 10. But remember, the increase in the concentration must be of H plus must be equal to OH minus. H plus increases, OH minus increases, and the increase will be equal. If H plus increases, pH must decrease, because pH and H plus are inversely proportional. POH and OH minus are inversely proportional. So, pH and POH both will decrease. That means, pH plus POH will not be equal to 14, because this value is decreasing. So, these two also decreases. So, remember, with increase in temperature, number of H plus increases, number of OH minus also increases by same factor. Therefore, Kw will increase, right? Whereas, since H plus increases, pH will decrease. Since OH minus increases, POH also decreases. So, pH and POH scale will decrease. It can be 13, 12, 10, 11 like that. But remember, the solution still, the nature of the solution, water, still remains neutral. Why? Because the increase in the number of H plus is exactly equal to the increase in the number of OH minus ion. Therefore, it still remains neutral. So, whether you take water at 25 degrees Celsius, 30 degrees, 35, 40, 45, 50, 60, 70, 80, 90, the nature of the solution of water will be neutral, because the increase in the number of H plus will be exactly equal to increase in the number of OH minus. But remember, pH here it is 7, but here it will be less than 7, because it is decreasing. POH also 7, but here it will be less than 7. pH and POH will decrease, because both H plus and OH minus concentrations are increasing. Remember. So, with increase in temperature, pH of water will decrease. It does not mean that it becomes acidic. POH also decreases. It does not mean that it becomes basic, because the increase in the number of H plus and the increase in the number of OH minus are exactly equal. Since they are inversely proportional, if H plus increases, pH will decrease. If OH minus ion increases, POH will decrease. So, both pH and POH will keep on decreasing, but still solution remains neutral. So, what is the pH of boiling water? Answer is less than 7. If you want to find the exact value, remember to find Kw. So, once Kw is given, pH equal to POH equal to pKw by 2. Use this equation, you will get pH and POH. But remember, they must be less than 7. So, this is about water and boiling water, pH. So, let us see how to calculate H plus ion concentration, because it will not be given directly many times. Let us see how to find pH and POH depending upon the medium. So, we are going to study calculation of pH and POH. Calculation of pH and POH. Case 1. Weak acid. So, if the given system contains weak acid, we know that weak acid is a weak electrolyte. A weak electrolyte dissociates partially. So, if it dissociates partially, what is the H plus ion concentration? At equilibrium. Already we have studied H plus ion concentration is equal to C alpha or root over Ka into C. So, while writing the dissociation constant for weak acid, we have found that H plus ion concentration at equilibrium is equal to C into alpha or root over Ka into C. So, we have to find pH. What is pH? pH equal to minus of log H plus. So, minus of log H plus is nothing but C alpha, or you can use this equation if it is given, minus of log Ka into C whole power half. This is equal to half minus log Ka minus log C, half pKa minus where what is the initial concentration of weak acid? Right, alpha degree of dissociation of weak acid, Ka dissociation or ionization constant of weak acid. So, if C alpha is given, use this equation. K and C of weak acid are given, you can use these relations. So, this is for weak acid. Similarly, let us find for weak base. So, if the system contains weak base, base releases OH minus ions, base releases OH minus ion. So, the system contains OH minus ion. So, we have to know OH minus ion concentration. So, OH minus ion concentration at equilibrium is equal to C alpha or root over Kb into C, same. Only the difference is instead of Ka you will get Kb. So, apply. So, once OH minus ion concentration is known, so we can find POH directly. So, minus log of OH minus ion concentration, which is equal to minus log of C alpha minus log of KBC whole power half. So, upon simplification, what you will get? PKB minus log C, where C is initial concentration of weak base Kb, dissociation constant of weak base alpha degree of dissociation of weak base. For strong acid, let us take one example, HCl and pH. Suppose if I take acid solution, acid and water. Just now we have studied that if it is acidic, the pH will be less than 7. Water pH, POH must be equal to 7. Of course, at 25 degrees, that is understood. For acid, pH must be less than 7. Right. So, let us take different concentration, 10 power minus 1, 10 power minus 2 molar. Say you have prepared different set of solutions. Different set of HCl solution. Now what is the pH of 10 power minus 1? 1, pH 2, 3, 4, 5, 6, 7, 8, 9, 10 and so on 14. Right. So pH of HCl can be 1, 2, 3, 4, 5, 6. It cannot be 7 or it cannot be 8, it cannot be 9. Why? If it is 7 or greater than 7, it indicates that HCl is basic in nature, but HCl is acid. If it is acid, its pH should be always less than 7, because the pH of water itself is 7. That means for this, from here our calculation is wrong. Although it is HCl solution you have prepared, but still the calculation is wrong. For this, your calculation is right, because it indicates that pH is less than 7. So we have done a mistake here. What is the mistake? Let us say, when you take strong acid solution, that means strong acid solution, that is nothing but strong acid plus water. Strong acid plus water. Strong acid releases H plus ions, no doubt. Water also to some extent releases H plus ions. If the H plus ion concentration from strong acid is considerably greater than H plus ion concentration from water, then you can neglect this. Then you can neglect the contribution of H plus from water. But if the concentration of H plus from strong acid is equal to or less than the concentration of H plus from water, then we cannot neglect the contribution of H plus from water. So what I am trying to say is, the total H plus ion concentration we have to find. The total H plus ion concentration is equal to H plus ion concentration from strong acid, SA, strong acid, plus H plus ion concentration from water. This is equal to H plus ion concentration from strong acid. What is H plus ion concentration from water? Nothing but 10 power minus 7 molar. Of course, temperature we have to write 25 degree Celsius. So there are two cases. If concentration of H plus from strong acid is greater than or equal to 10 power minus 6 molar. If concentration of H plus from strong acid is greater than or equal to 10 power minus 6 molar, right? Or you can say greater than 10 power minus 7. Let us write like this also, no problem. Greater than 10 power minus 7 means here 10 power minus 6, 10 power minus 5, 10 power minus 4, minus 3, minus 2, minus 4, in this area, right? If concentration of H plus is greater than strong as H plus from strong acid is greater than 10 power minus 7 molar, then this indicates that it is concentrated acid, stronger acid, and the contribution of H plus is greater than 10 power minus 7 molar. Therefore, I can neglect this value. This value means contribution of H plus from water. This is an approximation. Then the total H plus ion concentration, if I neglect this value, then total will be equal to H plus ion concentration from acid itself, approximately equal to strong acid, because you are getting the correct result. But if concentration of H plus from strong acid less than or equal to 10 power minus 7 molar. Now see here, if it is less than or equal to 10 power, less than means 10 power minus 8, minus 9, minus 10 up to minus 14 in this area, right? That means the H plus ion concentration from strong acid is equal to or less than the contribution of H plus ion from water. Then this source contributes more H plus ions to the system than the strong acid itself, because it is a very dilute solution, very dilute acid solution, not a concentrated one, very dilute solution. In that case, we cannot neglect the H plus ion contribution from water. If you neglect, you will get the wrong answers. So in this case, We have to consider the dissociation of water also, because the contribution from strong acid is very less, because the solution is very dilute. H plus from strong acid plus 10 power minus 7 molar at 25 degree Celsius. Once you get total H plus ion concentration, then find pH. pH is minus log of total H plus ion concentration. As I said, you have to write, actually the correct one is H3O plus, because in aqueous solution H plus does not exist, but by default most of us write as H plus itself. Right. So remember here, this H plus ion concentration from strong acid is nothing but normality of strong acid if normality is not given. If molarity is given, then molarity of acid into basicity of acid. So let us see some examples, you will understand. So let us calculate the pH of 10 power minus 7 molar HCl. So what is the pH of 10 power minus 7 molar HCl? So if I proceed the normal way, what is HCl concentration? Of course, for HCl normality equal to molarity. So if I proceed the normal way, H plus ion concentration is 10 power minus 7 molar. So pH equal to minus log H plus minus log 10 power minus 7. So minus of minus 7 into log 10, this is equal to 7. But your answer is wrong, because acid solution pH should be less than 7. So what is the mistake I have done? This is a very dilute solution. We have to consider the dissociation of water also. So this is the other way. First to find, since it is very dilution, first to find total H plus ion concentration. What is total H plus ion concentration? H plus from HCl plus H plus from water. So this is 10 power minus 7 plus 10 power minus 7, right, at 25 degrees Celsius. For HCl molarity equal to normality, for water also molarity equal to normality. So this is directly normality. So A plus A, like 2 into 10 power minus 7. So although it appears as 10 power minus 7 molar solution, but total H plus ion concentration is 2 into 10 power minus 7. Then find pH. So pH equal to minus log H plus total minus log 2 into 10 power minus 7 molar. So this is minus log 2, right, plus log 10 power minus 7. So this is minus log 2, log 2 is 0.301, this is log 10 power minus 7, that is nothing but minus 7 log 10 to the base 10. Sorry, we have minus here, right? Okay, I will write minus here, आगे minus log. Okay. So this is anyway log 10 to the base 10 is 1, minus into minus plus 7, 7 minus 0.301. So 10, like 1 with 9, 9, 3, 6. This is the correct answer, 6.699, 6.699. You can also do one more important bit. Suppose if I take 10 power minus 8 molar HCl, if I proceed normal way, pH equal to minus log 10 power minus 8, this is minus of minus 8 log 10 to the base 10, which is equal to plus 8, but pH of acid cannot be greater than 7. right. So, what is the problem? The problem here is it is a very dilute solution, so dilute that we cannot neglect the dissociation of water. So, what I have to do is find the total H plus ion concentration. Total H plus ion concentration is equal to H plus ion concentration from HCl plus H plus ion concentration from water. For HCl, molarity equal to normality. So, 10 power minus 8 molar is nothing but 10 power 8 minus 8 normal. For water, it is 10 power minus 7. So, I can write it as 10 power minus 1 into 10 power minus 7 plus 10 power minus 7. I can take 10 power minus 7 common, 10 power minus 1 plus 1 into 10 power minus 7. So, this is 1.1 into 10 power minus 7. So, actual total H plus ion concentration is 1.1 into 10 power minus 7 molar. So, let us find pH minus log of 1.1 into 10 power minus 7. So, this is minus log 1.1 plus minus log 10 power minus 7. So, log 1.1 is 0.0414, log 1.1 is 0.414, and this is minus of minus 7 log 10 to the base 10. So, you will get 7 minus 0.414. So, this is 6.99459181046. So, the correct answer is 6.9586. 6.9586. So, if you see the option, if this is not present, then prefer less than 7. If less than 7 is not present, prefer approximately 7. If this is also not present, then you can write equal to 7. But first priority should be check for whether 6.9586 is present in the given option or not. If this is not given, then go for less than 7 always. If this is not given, then go for this. So, first preference should be the correct answer, that is 6.9586. It cannot be 8. Similarly, we can write for bases. So, I will write the equation for bases. So, before that, I would like to give you the log values. So, I will give log values. So, copy the log values. Log 1 to the base 10 is 0, log 2 this is 0.301, log 3 0.477, log 3 0.477, log 4 this you can write it as log 2 into 2, this is 2 log 2. So, 2 into log 2 is 0.301, which is equal to 0.602. Next, log 5 0.6989, sometimes approximately you can take it as 0.7 for easy calculation. Log 6 you can write it as 2 into 3, 6, 2 into 3. So, log 2 plus log 3. Log 2 is 0.301, log 3 is 0.477, add what we get is 0.778. Log 7 0.845, log 8, log 2 cube is 8. So, this is 3 log 2, this is 3.301, 0.903. Log 9 is nothing but 3 square, 2 log 3, 2 into 0.477, 2 7s are 14, 14, 15, 8, 9, 0.94. Log 10 to the base 10 is 1, log 100 is nothing but log 10 square, that is 2 log 10. 2 log 10 is 2, log 10 is 1, therefore 2 into 1 is 2. Log 1000 is log 10 power 3, that is 3 log 10, that is equal to 3. Log 0.1 is log 10 power minus 1 equal to minus 1 into log 10. Log 10 is 1, therefore it is minus 1. Similarly, you can write log 0.01. 0.01 is log 10 power minus 2. Log 10 power minus 2 is minus 2 log 10. There is nothing but minus 2. So, these are the log values. You can copy it. Now, let us find the pH of strong bases. That is the next case. For strong base, right. So, same case 1. So, strong base solution is nothing but strong base Sb plus water. So, both will contribute OH minus ion. Same condition, if the concentration of OH minus ion is considerable, that is greater than 10 power minus 7, then you can neglect this, otherwise you have to consider. So, here total OH minus ion concentration from strong base plus OH minus ion concentration from water, which is equal to OH minus ion concentration from strong base plus 10 power minus 7 molar at 25 degrees Celsius. What is OH minus ion concentration from water? At 25 degrees it is 10 power minus 7 molar. So, case 1, if concentration of OH minus from strong base is greater than 10 power minus 7 molar, then you can neglect the contribution of water. You can neglect the contribution of OH minus from water, then OH minus total. If I neglect this, then this is approximately equal to OH minus ion from strong base itself. But if this is less, so less, it is equal to or less than OH minus ion. If OH minus ion concentration from strong base is less than or equal to 10 power minus 7 molar, then we have to consider. There is no other way. If you do not consider, your answer will be wrong. So, once you get total OH minus ion concentration, find pOH. pOH equal to minus log OH minus total. If you want pH, it is 14 minus pOH. Right? Once you get pOH, find pH. 14 minus pOH. Now, remember, OH minus ion concentration from strong base must be equal to normality of base. If molarity is given, convert into normality, molarity of base. So, what is the valency? Acidity of base? Acidity of base. You can use this equation and you can solve it. So, this is about strong base. So, we have completed weak acid, weak base, strong acid, strong base. So, we will complete the remaining relations also. So, mixture of two weak acids, mixture of two weak bases. Next one. So, if two weak acids are given, say HA1 plus HA2, HA1, HA2, two weak acids in the same system. So, its dissociation constant is Ka1, its dissociation constant is Ka2, its initial concentration is C1, its initial concentration is C2. Then, what is H plus, total H plus ion concentration equal to H plus ion concentration from HA1 acid 1, H plus ion concentration from HA2, which is equal to root over Ka1 C1 plus Ka2 C2. Ka1, Ka2 are dissociation constants of respective acids. C1, C2 are their initial concentration. Once you find pH total by this equation, sorry, H plus total, then apply pH definition. So pH equal to minus log of total H plus ion concentration. If you want to find the concentration of conjugate base A1 minus, this is conjugate base of acid 1, then this is the equation Ka1 C1 by root over Ka1 C1 plus Ka2 C2. We can derive this, right? Conjugate base of acid 2. So these are the equations. Similarly, you can write for weak base, mixture of two weak bases. Same equations, mixture of two weak bases. So let us take base 1 BOH1, base 1, another base BOH, base 2. Say its dissociation constant Kb1, initial concentration C1, its dissociation constant Kb2, initial concentration C2. So total OH minus ion concentration is equal to OH minus ion concentration from base 1 plus OH minus ion concentration from base 2, which is equal to Kb1 C1 plus Kb2 C2. So once you get OH, then find POH minus log of OH minus total, you will get the answer. So then find pH 14 minus POH. If you want to find conjugate acid, then you have to divide Kb1 C1 with this formula. Similarly, conjugate acid of base 2, Kb2 C2 by this formula, similar way you have to write. So one more we have, that is mixture of acid and base. Say you have an acid and base, you may add water, that depends. So finally we will get a solution. So total volume V. It can be acidic, basic, neutral, because you are mixing acid and base, they are chemically reacting. So if molarity is given, convert into normality. So normality of acid will be given, volume of acid, find NaVA, normality of acid into volume of acid. Similarly, normality of base, volume of base will be given, then find NbVb, right. So case 1, if NaVA greater than NbVb, then resulting solution is acidic. Already we have studied this. Resulting solution is acidic. If it is acidic, it contains which ions? H plus ions. So H plus in the resulting solution, mixture, I am writing mixture, H plus in the resulting solution is equal to what? Chemically reacting. So higher value, NaVA minus NbVb by total volume. Once you get H plus ion concentration, then pH equal to minus log H plus. This is case 1. Case 2, if NaVA less than NbVb, then resulting solution is basic in nature. That means it contains more OH minus ions. So OH minus ion in the final mixture, OH minus ion in mixture is equal to, right, nothing but normality of solution equal to NbVb minus NaVn. You can write normality N. If it is acidic, it contains H plus. If it is basic, it contains OH minus by total volume. So since we got OH minus, you can find POH minus log OH minus mixture, then find pH 14 minus POH. If both are same, then it is neutral. Resulting solution is neutral. Already we have studied these formulas. So if it is neutral, then pH must be equal to POH equal to 7, of course at 25 degree Celsius.